So thank you all for joining us this afternoon as we host our weekly conservation webinar series for the Iowa Learning Farms. I'm Liz Ripley. I'm the Conservation and Cover Crop Outreach Specialist with the Iowa Learning Farms. And I'm pleased today to have with us some researchers from the USDA Agriculture Research Service, Rob Malone, Claire Phillips, Peter O'Brien, and Doug Karlen, sharing their research on corn stover harvest impacts in central Iowa. So if you have questions for our presenters today, please feel free to submit those in the chat to me. And then following the presentation, we'll have some discussion and question and answer time as well. So at any point in the presentation, submit those questions in the chat to me, and I will turn the virtual floor over to you all. Thank you again for joining us today.
Yeah, I'll get us started off. Thank you so much, Liz, and thank you to Iowa Learning Farms for this invitation. I'm happy to be part of this group sharing lessons learned from stover harvest research conducted at the National Lab for Ag and Environment, which was started in this research program started in the early 2000s by my esteemed colleague, Doug Karlen. And Rob, Peter, and I have been involved in the research in more recent years. And so we have some long-term studies to report on. Let's see. The ARS research on corn stover came on the heels of the 2005 billion ton study, which was a DOE report that established that there was sufficient feedstock from agricultural and forestry sources to meet long-term goals of supplying or offsetting 30% of petroleum production with biofuels. And as a next step, ARS established a network of a multi-site national research effort to look at environmental effects of residue removal and characterize soil health impacts and provide guidelines to industry on sustainable stover harvest. And at the same time as a biofuel economy was being envisioned, high levels of stover biomass were becoming an increasing challenge for management. And that's shown here with this figure demonstrating that older, lower yielding hybrids produce less stover biomass than modern high yielding hybrids. And so this is showing over the course of the growing season with growing degree day accumulation. A hybrid variety from the year 2000 accumulated not only more grain, but also more stover biomass than an older hybrid. And these higher yielding hybrids also do have lower nutrient density, which presents challenges for decomposing the material and for planting into high residue loads. And so what we've been tasked with is to understand whether this stover biomass is more than is what's needed to return to the soil to sustain soil health, or whether we should be concerned about losses of organic matter, removing nutrient reserves, reducing soil carbon stores, increasing risk of erosion, contributing to soil crusting. And another concern with stover harvest is that it might result in soil compaction from the loss of soil biology, which is important for soil structure and aggregation, but also just from higher wheel traffic loads from more equipment passing over the field to harvest the stover and remove the material. So Doug Karlen established a trial outside of Ames in 2008, and I just want to remark, this has so many treatments, and it has 22 treatments, and it's been a big project over many years. So within this trial, there is continuous corn managed with either complete residue retention or medium or high level of removal, equating to about 50% of what can be reasonably harvested of the stover. And the high removal level would be all of what could be reasonably harvested. And this is evaluated both in a no-till and a chisel plow system. and other treatments, which we won't get to talk about today, but they looked at whether other regenerative practices could help to balance or offset potential negative impacts of residue removal. So treatments looked at increasing crop diversity. One rotation involved an alfalfa phase to try and increase perennialization and root biomass. And then we'll also get to hear from Peter about the biochar treatment, with the idea being that some of the carbon material removed could be replaced with a more persistent carbon form in biochar. Other efforts that ARS was involved with were collaboration with Iowa State's Stuart Burrell to develop one-pass harvest technology. And so these are pictures of how that technology developed over time, where the stover was originally harvested into wagons and later baled. And so the trial results that we'll show you are adaptive management in terms of the harvesting technology, from 2-pass to various forms of 1-pass equipment. And so while we haven't really seen development of a commercial cellulosic ethanol fuel production, we did want to mention that there is a plant in central Iowa, Verbio, which is producing renewable natural gas, which is an anaerobic digestion of corn stover material. And this has become the main form of biofuel produced from corn stover over time. And so this interest in biofuels and bioproducts with corn stover is persistent. So we're going to present over the next 20 minutes some of the sustainability indicators of this stover harvest practice. So I'll share grain production, grain yield results, and also a study we did a couple of years ago on soil compaction. And Peter's going to be presenting work he did to evaluate soil carbon changes, both the total carbon stocks and the more active form of carbon. And Rob's going to be sharing results on potential losses of nitrogen with impacts to waterways. So this figure here is showing the average results overall from 2008 to 2020 for grain yield, with chisel plow practice on top and no-till on the bottom. And the result was that residue removal didn't hurt yields, and in some cases did improve yields from continuous corn production. I'll point out that for the no-till, no stover remove practice, this did not perform well and was eventually discontinued. So we don't have the data for that. Within the chisel plow practice, there was increase in yield that equated to about 15.7 bushels per acre, going from complete stover retention to the high removal rate. And within the no-till practice, there was no difference between medium and high stover harvest. I break out the years here because I just wanted to make the point that most of the difference was occurring in 4 years. There was kind of a trend across time, but the significant differences were in 4 years. And early in the study, Doug and his group were implementing a variable end rate with the idea that the stover harvest was going to remove nutrients. And so they were supplying extra nitrogen to help make up for that removal. And then based on soil fertility tests, it seemed not really to be necessary. So that was discontinued after the first 4 years. So that additional N to the stover remove treatments might be part of the yield benefit we see here, but it doesn't explain the entire effect. No differences in yield between the chisel plow and the fall chisel plow and the no-till practice. And I just want to suggest an interpretation of this being that no-till can be used in continuous corn production without yield reduction, but we do see that some level of residue removal is required as the complete retention practice just wasn't effective. And another way of thinking about it is that removing some stover material can be kind of an entry to implementing no-till within a continuous corn practice. I want to mention that there were 2 other trials that were contemporaneous with this one in central Iowa, with Iowa State folks involved there. And these were corn soybean rotation trials, and the findings were quite similar. At the Bruner site, there was an increase in the corn phase grain yield with going from complete retention to moderate removal. At the Boyd site, there was no impact of stover harvest. And these results are pretty consistent with what Doug has reported for synthesizing the entire ARS network. Some locations had yield declines with stover harvest, but most did not. So there it is, as we're thinking about the take homes from this, there is some specificity with like where we're talking about. But for central Iowa, it seems that stover removal can be sustainable. And that's what the authors of this paper concluded. But caution also that there is particularly removal of potassium with stover harvest. And so monitoring that closely is necessary. And they recommended considering a lower level of corn stover production when making decisions. So the suggestion was for a no-till system, consider this as an option if the site is producing 175 bushels per acre on a regular basis as a baseline. So I'm going to shift gears and talk about the soil health effects. And we took measurements in 2021, so it was after 12 or 13 years of harvest removal, to look at soil compaction effects using an implement like this, which is a hydraulic cone penetrometer. So we can press a rod into the ground up to a meter depth and measure resistance to penetration. And so this is a proxy for compaction. And what we were interested in looking at here is, yes, does stover harvest cause compaction, but also trying to figure out how much of that is due to wheel loads and how much of that effect might be due to actually removing organic matter and removing the residue cover. And so we took measurements that were in the most trafficked lanes of the field. And so this kind of background image is showing where where the wheel traffic was happening from all the field operations. And so they were stacked up between rows 2 and 3. And between row 8 and 9 was the least trafficked portion of the field. It was not a controlled traffic study, so it wasn't pristinely untrafficked, but the least trafficked portion of the field. And so the idea was, well, if we're seeing impacts of residue harvest in the least trafficked area, then this is probably an effect of just not having much organic matter return to the soil. But if we're only seeing compaction effects in the most trafficked area, well, then probably we're seeing an effect just of increased wheel loads causing the compaction. And it was that latter situation that proved to be true. So the least trafficked areas were not affected by stover harvest practice. The most trafficked areas were, and this was really the case in the chisel plow situation. So in no-till soils tend to be more compacted anyway. And that also results in a higher load bearing capacity. So that was what we found here, is that it was just the chisel plow practice, and the no-till did not have any symptoms of increased compaction from stover harvest. So the conclusions from the compaction work is we did measure a compaction effect from stover harvest. It wasn't very large, and I wouldn't really consider it a problem. It was less than the compaction from going from chisel plow to no-till. but it's always a good idea to consider field wetness to try and avoid compaction when making decisions about timing of stover removal. And Peter's going to tell us more about the impacts on soil carbon.
Yeah, hi everyone, and thanks very much, Claire, for that great introduction, and actually a really good segue into talking about soil carbon, because it's so closely related with compaction. And so I'm kind of going to talk about soil carbon and kind of talk about overall carbon losses in these stover removal systems. And it's kind of important to think about it in two ways. So when you're removing the stover, you are actively taking some amount of carbon off the field that would otherwise have been left there. And you can see on the picture on the right really clearly that when you don't remove that corn stover, you're really changing the environment at the soil surface. So kind of the first step is the direct removal of the carbon. And then the second step is kind of the indirect of altering that environment at the soil surface. And what that is doing is it's changing the amount of residue there for microorganisms to degrade and release as CO2. And it's also changing soil temperature and soil water contents, which then play back into the activity of those microorganisms again. So if we can click through there, Claire. Yep, so I'm going to kind of share some results from that same field study that Claire described, trying to quantify those carbon losses. And this is just kind of a reminder of the treatments here. We have the two tillage and then 3 levels of stover removal. And then again, I'm going to just touch briefly on biochar application as well. So in terms of how we measure this, measuring carbon loss in stover is pretty straightforward. You measure the amount of stover you took off, you take a subsample and measure how much carbon is in that. Then you can do the math to see how much carbon is directly removed. The CO2 or the carbon dioxide losses in carbon are a little more complicated. And what we did is we have, you can see there on the left, CO2 survey chambers. Basically, we go out and plop a chamber down with a gas analyzer, hold it there for a couple minutes, and measure the CO2 fluxes coming out of the ground. We did that once every week or every other week over the course of 3 years from 2010 to 2012, as well as monitoring soil temperature and water content and the carbon losses in the plant material as well. We shoved that all into a modeling system called the APSIM, Agricultural Production System Simulator. And that spit out for us this nice figure. And so basically what this is showing is all of our filled points are actually measurement points that we got with the CO2 chambers. And then all of the lighter bars in the back are the filled in, the gap filling procedure, basically using APSIM. And so what we got is a CO2 loss per day for each of our different treatments. And yep, that's perfect, Claire, thank you. And so in the end, we had really nice model performance that led to this figure, which is kind of complicated, but tells, I think, two and a half interesting points. And so on the left, you can see that this is the amount of carbon lost in these stover removal systems over the course of a 3-year study. And then across the bottom, we have our 3 different treatments, conventional till, no-till, and then the biochar treatment, which was also plowed in the fall. And then within each of those treatments are 3 levels of stover removal. And our bars there are showing the two pools of carbon loss, basically. So the CO2 that we were measuring is the filled bar with colors, and then the stover carbon that was directly removed is the white bar on top. And so you can see really clearly that when you do remove corn stover, you're reducing CO2 losses. This was consistent across all the treatments, all 3 years. This one was one of the more consistent results that we found. And I think it makes sense, and I think it's really closely tied to that change in the microbial substrate, where you're removing that material that would otherwise be degraded and released as CO2. But the offset to that is that while those CO2 losses were reduced with stover removal, when you combine that with what was directly removed from the field, you always have an increase in carbon loss. And you can see with all these different letters up here, it's kind of messy, the statistics, but generally that trend was very consistent as well, where there's always higher losses in carbon in the stover removal system. And then the last half point is that in the biochar, the three purple ones on the right, we're not seeing any increased carbon losses, right? And so that's important because in 2007, they went out and applied quite a lot of carbon in the form of biochar to these plots. And since they are not seeing increased losses, we are actually seeing on the next slide a slight maintenance of higher soil carbon in the biochar treatments. And this is kind of the end game for a lot of people with when you're thinking about carbon is what's your soil carbon level, total soil carbon. Thinking about carbon credits and carbon sequestration and soil health, all these things come back to this one measurement oftentimes. And in 2012, you can see across all of the stover removal treatments, there's a little bit of variability, but we're not seeing any changes associated with stover removal. And if you fast forward to 2021, we see the same finding, that even additional 9 years of this stover removal is not decreasing total soil carbon stocks. And this is kind of at odds with what I was sharing on the previous slide, where we were seeing, a slight increase in losses with the stover removal, especially in terms of combining CO2 with direct removal. And I think that comes down to segmenting the different carbon pools, thinking about active carbon, which is more readily degrading in the form of CO2. And I think if we partition these pools out, we might see some differences, but overall, over the course of this 13 years of stover removal, we're really not seeing any changes in the soil carbon. So that's the carbon story, and we'll pass it off to Rob to talk about nitrogen.
Well, thanks, Peter and Claire. They gave a lot of good information, and I'm just going to talk a little bit about the nitrogen budgets. And from that field study and some of the work Doug did and others, we noticed there wasn't a lot of information in the literature about N budgets with corn stover harvest. And so then we decided, well, let's do a modeling study of this and look at the N budgets in some detail. And so this is a simplification of a nitrogen budget here with the crop uptake and precipitation N and crop residue N and leaching into the tile drain and soil humus N availability and that sort of thing. So next slide there, Claire. Here's I think we saw this similar slide with Claire or Peter, but we have the moderate and high levels of stover harvest, and we worked in the model with the moderate level of removal. That seems to be the most reasonable, and what some other people said, that you don't want to remove as much stover as possible. You want to leave some out there. And so that's what we did, was moderate levels. And next slide. And so we did a study, and we published this in 2019, looking at corn stover harvest and then energy budgets in central Iowa. A few takeaways. These are the kind of the main takeaways of the study, was that we found that additional N fertilizer to replace the N removed wasn't needed. This seemed to be in line with some other field studies and the studies that Claire and Peter just mentioned. So no additional N was needed. And that's in contrast to studies, a lot of the modeling studies that looked at corn stover harvest added additional N fertilizer to make up for the N removed. But we found, at least in central Iowa, we didn't need that. Very, very small soil C loss over time. It was would have been unmeasurable, the amount that was lost. And then we did some kind of back of the envelope net energy ratios, like how much energy is involved with the do you get from this corn stover, and how much energy is input to harvest that stover, etc. So next slide. There. So this is a look at a few of the studies that were published previous to our study, the modeling studies that said, well, we're going to add N fertilizer if you're going to remove corn stover as an energy source. We're going to add some additional fertilizer, and just showing that our study showed we didn't need that. A lot of the other studies show you didn't need the added N fertilizer. Next slide there, Claire. This is one study. I don't think Claire or Peter mentioned this, but that figure there shows a study from 2013, and you have grain yield and fertilizer rates with stover removed and stover retained. And the stover removed actually had higher yields. So this has been seen in several studies around the Midwest. You get higher yields with the stover removed. Next slide. This is the energy net energy ratio that we determined from our modeling study, and it's kind of a messy, lots of information here on this bar chart, but just look at those circles there, and the lines point to the net energy ratio in those circles that you might want to look at. The RR post is residue removed. That RR post is post fertilizer, post emergence of your crop when you put the fertilizer down, and so that had the highest net energy ratio. So it was positive from a energy standpoint to harvest the stover. Next slide. This is the soil C. So I think Peter indicated that the soil C didn't change much with the stover harvest, and that's what we found in the modeling study. That figure in the top right shows our modeled soil C with stover removed or stover left on the field. And there's a very, very small amount of C reduction with the residue removal, but it would be undetectable. You can see those units on the, I think that left Y axis. You're talking about unmeasurable amounts of soil C, that the difference between stover removed or retained. Seemed to be in a line. This also seemed to be aligned with some other studies. This Campbell study, and I can't, for some reason, on my slide, I can't see the dates there, but it looks like it was 2014, and so anyhow, some other studies showed that too, that from long-term field and modeling studies, the soil C doesn't change much. So next slide. Now we're back to this nitrogen budget again, and a few takeaways here. We had a corn-soybean rotation in our study. We didn't do continuous corn. The N removed in the stover was 9 kilograms per year, but in the corn years, it's 18 kilograms per hectare per year. So only removing it every other year, moderate levels of removal here. So you're removing about 18 kilograms per year in the corn years, but we don't need to replace that with extra N fertilizer. At least that's what our study found, and seems to be in line with some other field studies. Drainage N was the same with both, even though you're removing a good bit of N. And you don't need the extra N, mostly because net mineralization our model was telling us it was about the same for the stover removed or the retained. So gets a little complicated on some of the things with the N budget. There's only and anyhow, there's you don't need to add the extra fertilizer N, and those were a couple of our main takeaways there. So thank you.
All right. So once again, if you have questions, follow up any questions to anything that was presented today or clarification, please feel free to submit those in the chat. But while we do so, please, if you attended today for a CCA CEU, please email Elena Whitaker at alenaw@iastate.edu by 5 p.m. today with your name, the name you watched to enter the webinar if that's different, and your CCA number, and she will get that submitted on your behalf to earn that credit. So go ahead and go to the next slide. Thank you very much. And again, if you've joined us before, you've seen this, but if you're new this week, we do ask that you please fill out this voluntary survey. You can scan the QR code on the screen to access it on your device, or simply submit via iowalearningfarms.org/survey. You only need to do one response per calendar year. It is voluntary. To collect some demographic information as a USDA funded program, we're asked to collect that information as best as we can. So again, if you're willing to do that quick survey, you can check out that QR code or visit us at iowalearningfarms.org/survey. And then next week, we have Jeff Strock with us, professor and soil scientist at the University of Minnesota. And he is going to be discussing crop response to excess and deficit water stress. So we've definitely been seeing some water stress. So we hope that you can join us next week, again at noon Central Time for this webinar. So we've got some questions coming in, so feel free to keep those questions coming in, folks. So the first question, did the researchers determine if additional phosphorus fertilizer was needed with the moderate or high levels of nutrient stover removal? Excuse me.
Doug, do you know that? Oh, you're muted, Doug.
Here we go. Yes, we measured not all the macronutrients and of course a lot of the micronutrients in the course of these studies. Generally speaking, phosphorus soil test levels in most Iowa soils are well beyond what's going to have a drawdown. There really was no need to increase the P from your routine fertility program just because you implement corn stover harvest. Again, I just, a very strong advocate of routine soil test monitoring on say a 5-year basis at a minimum. You'll be fine in taking care of that. The biggest one is, as pointed out by Claire there, was actually the potassium, and that comes in because potassium was one of those nutrients that tended to get ignored in the Midwest for too many years. And when you go to any kind of a biomass removal, and of course, having grown up in the alfalfa area, that was where potassium really hit home very quickly. But your K is what will increase dramatically when you pull it off, and it'll be especially high if you pull the residue off when it's at a higher moisture content. I mean, obviously, corn silage was the traditional example when you really pulled a lot of potassium off.
All right, so our next question here kind of has 3 parts. Most stover-based refineries will produce a digestate that could be reapplied to cropland. How might that change the soil carbon?
I don't know if anyone's done digestate studies in our lab, and it's an interesting one. I know I've worked with Penn State on this, and they have, I think, or at least aware of some studies that have done digestate and like how it adds fertilizer to the soil. I'm not sure about other soil health or indicators like carbon, but do you know of anyone else know more about that?
Oh, I haven't seen anything like that, but I think any soil amendment, kind of regardless of how much carbon they actually have, Iowa soils are very resistant to changing in carbon levels, especially total carbon. So I suspect you probably wouldn't see a big change with that addition.
And then related to that, there's two sub questions here. What if we need to account for transport and application for the carbon emissions? And then any potential impact on crop yield from that digestate?
Yeah, I think at least on our energy budget, we only did to the farm gate. We didn't do anything down, I guess you want to call it downstream of that as you left. And there was with that modeling study, we did do you know, some of the gas. I think it was actually in one of those figures on that bar graph. Claire, I don't know if you can go back to that, but there was a and this was the Penn State component of that one there. They did do some greenhouse gas intensity study with the stover removed and you know, no stover, the no residue removal. But that part of the study was mostly Penn State, and I was aware of it at the time, worked on it a little bit, and Brian Emmett from our lab did a little bit of work, and I don't think he's on the call today. I could ask him. He helped with some of this analysis and data, but you know, it was positive. You can see that greenhouse gas intensity with the residue removal, at least at the farm gate, it was better with the stover removal. That's because you're dividing it by how much energy. I think that greenhouse gas intensity was you know, the amount of greenhouse gas emitted and then divided by how much energy you got from the system.
Yeah, I'll just add a general comment. So I'm not familiar with digestate. I've been looking at a few more comprehensive analyses of compost and whether that should be considered a climate smart practice. And there's kind of similar in that we're in both situations, we're talking about like a translocation, moving carbon from one place to another and nutrients, right? So, you know, in general, it's a really good question about two things, like where you draw the boundaries of what you're evaluating. And I think this is really essential to look at the transportation component too. But the other part is, well, what is the business as usual that you're comparing to? So that raises questions about if you leave the digestate where it is, what is its fate? What is the fate of that carbon? But also, I don't know if this is like a nutrient intensive thing. If that isn't returned to the soil, let's say it's rich in nitrogen or phosphorus, then a really thorough accounting looks at what it takes to mine phosphorus and to produce nitrogen. And so these are really important questions about what if we include this, what if we include this, and it's a real challenging endeavor to really be comprehensive in the assessment. So, yeah.
So a question here in terms of stover, like what percentage of stover is removed in Iowa? And what is like you mentioned there's a little bit of biorefinery, but what is the most common use for corn stover? Is it for energy production or say livestock bedding? When we think about some of this net energy.
Yeah. Doug, do you know that?
Probably more is taken off for animal feed and bedding usage and that than actual energy production. Of course, you know, with the Rebio plant now coming back on board in the old DuPont facility there in Nevada, that's having a change. And I believe there's discussions going on about the cellulosic component of the Poet one up in Emmetsburg there, perhaps retooling and bringing it back online. But again, I'm not sure. Kind of lose track of that once you retire, where things are.
Yeah. and that's a good point on that. I know we weren't sure how to pronounce Furbio or Furbio, but appreciate Doug with that. And I think yeah, they are using the corn stover for anaerobic digestion, and I don't have the numbers on what the scale is or whatever, and I'm very interested in that. Maybe that's another Iowa Learning Farms presentation opportunity there.
Right. Yeah, one of the biggest things, the whole stover removal issue, and one of the reasons we wanted to take part of that off goes all the way back to when I was getting questions about, well, my yields are going up. How much more tillage do I need to do? And of course, this was my big mantra that, don't bring out the chisel plow or the subsoilers or things like that on our structured Midwestern soils. That's where you're better off to take part of that residue off and move toward the least amount of tillage that the producer can still get a good night's sleep with. Is sort of what the reason we came up with it there. Because there is a transition when you reduce that tillage intensity, the soil has to adjust, the operator has to adjust, but stover harvest does help in the right direction on that, and that's a big part of this whole understanding the system, in my opinion.
Well, thank you, Doug, for that final comment about the motivation for stover harvest is for reducing tillage in the first place for our great soils here in Iowa. So we thank you all for presenting, and we want to let you know that you can find all of our recorded webinars on our website each week. And thank you again. I'll give the last final word to our presenters if they have one final comment they'd like to make before we sign off this afternoon.
Ladies first, Claire.
Thank you. This was fun, and I'd love to come back anytime.
All right.
Yeah. Oh, I was just going to say thanks, Liz. Appreciate it.
Our pleasure. And thank you everyone for tuning in today. Have a great afternoon.
Thanks.